you are. Good day, good evening, good morning. I'm Ronald Jansen. I'm with the United Nations Statistics Division. I'm very glad to welcome you here to this webinar on data science and official statistics, with this part of the Road to Bern webinars. It's in anticipation of the United Nations World Data Forum, which will take place in October this year. So this webinar today, very glad with the lineup that we be able to have with you, and the hopefully the interesting discussion that we can get on this topic of data science and official statistics. Let me start by giving a little bit of a background where I'm coming from. So the United Nations Statistics Division is really serving and supporting the community of all national statistical offices around the world. We do this via the United Nations Statistical Commission. It's a gathering of chief statisticians every year in March here in New York, if possible. And a number of years ago, that community said, well, we should do more on how big data and data science can be used to improve and benefit official statistics, and with that improve and benefit data for policy purposes. So we created at that point in what is now called a United Nations Committee of Experts on Big Data and Data Science for Official Statistics. This committee is looking at, for instance, how we can use Earth observations, satellite data, remote sensing data, for agriculture statistics or environment statistics. We can use mobile phone data for a number of different official statistics, scanner data for price statistics, and the last few years we've also been working with the AIS vessel tracking, so real-time ship positions and speed of ships and so forth, which we use for maritime transport and estimations of trade. We also have in that committee privacy preserving techniques. There's a group working on that, and we will hear today from Andrew Trask on that work, which will help to get access to sensitive data while guaranteeing confidentiality and privacy. So we're looking forward to that as well. At national level, over the last years, we've seen that there is a data science entities that are stepping up next to the Office of Statistical Offices, the National Statistical Offices. For instance, the Data Science Campus of the Office for National Statistics in the UK. It was created in 2017, and more recently we have also the Data Science Competence Center, which was created in Switzerland next to the Federal Statistical Office of Switzerland. So we will hear about that, and we're also happy to have today representative of the let's say the private sector and open source community. We will start with Jyoti Nukula, who is working with Facebook. We will have Oliver Mahoney of the Data Science Campus of the ONS UK. We will have Professor Bertrand Loison, who is a Vice Director of the Swiss Federal Statistical Office and is also heading the Data Science Competence Center there. And then we will have Andrew Trask leading Openmined. Will also indicate how we can use data science while using privacy preserving techniques. So that I think is a very interesting lineup to this combination of the data science community and the community of official statistics. What we would like to see is a much more integration of the two, the complementarities and benefits of working together on issues. Is something very promising. A few housekeeping messages before we start. We're going to record this. I hope that the recording can be started. And which we also want to post on our website. If you have questions, please put them in the chat. Microphones have been disabled, but you really can take part in the discussions by putting your questions in the chat, and we will pick those up. A few maybe immediately after the presentation, but more of them towards the end at the Q&A session. With that, I want to start with the first presentation, opening it up. It is very happy to have Jyoti Nokula here. She is a product manager at Facebook. She works on PyTorch and responsible AI, artificial intelligence. Prior to work at Facebook, Jyoti worked at Amazon, developing deep learning products for AWS. Jyoti was also at that point featured as one of the 4 women at AWS who are making machine learning accessible for developers. And with that, I will share my screen for you, Jyoti, and then I'll give you the word. So
thank you so much.
Yeah. Let me share the right screen. Can you see that?
Yes, I can see that.
Okay, please go ahead and let me know when we have to switch.
Perfect. Thank you. Hey, so my name is Jyoti Nukula, and I'm a product manager working on PyTorch at Facebook. Next slide, please. So in this presentation, I'll be giving you an introduction of PyTorch and its ecosystem, its features, key concepts, and production at scale. I'll also highlight a few trends that we have noticed and tell you how that's driving some of the work we are doing throughout Facebook AI. Next slide, please. So what is PyTorch? PyTorch.org tells us that it's an open source machine learning framework that accelerates the path from research prototyping to production deployment. So let's unpack that statement. PyTorch is a software for machine learning. It contains a full toolkit for building and deploying ML applications. TorchVision, the PyTorch library for computer vision applications, also includes pre-trained models and packaged datasets to train your own. And PyTorch is also built to enable fast iteration on your machine learning models and applications. So you can work in regular idiomatic Python, and there's no new domain-specific language you need to learn to build your computation graph. And PyTorch has the tooling to work at enterprise scale with tools like TorchScript, a way to create serializable and optimizable models from your PyTorch code, or even your TorchServe, which is PyTorch's model serving solution and options for quantizing your model for performance. And also, finally, PyTorch is free and open source software, so it's free to use and open to contributions from the community. Next slide, please. So let's talk about some exciting trends. First, it's been very cool to see how much traction PyTorch has been able to gain throughout the research community. And seeing it show up in 70% of NeurIP's framework papers, it has been very validating. And so it's important for us to step back and think about what it was that made PyTorch gain so much traction so quickly. Next slide, please. So the benefits of usability eventually caught the eye of the production world. Sure, it took a little longer, but that's not surprising. The 2020 State of AI report highlighted some of the challenges of research to production and noted that adoption in production tends to trail adoption within research. And in the early days of PyTorch, many would have laughed at the thought of Python getting anywhere near production. The standard underlying assumption was that compute performance was all anyone would care about, and that with a captive audience of production focused software engineers, usability just wasn't a priority. But they were wrong. Usability does matter, and making things easier on software engineers, machine learning researchers, and data scientists frees them up to think about solving other problems in their domain. Next slide, please. So who are all of the people contributing to PyTorch? 60% of non-Facebook contributions come from a diverse team of contributors from many companies, all of whom are working to make PyTorch better. So these range from companies with specific interest in particular components of PyTorch to companies sponsoring employees to work generally on PyTorch as a whole. Next slide, please. But that's only 60% of external contributions. Another 40% comes from people all across industry, academia, and hobbyists who don't necessarily work on PyTorch full-time. And even if you're in full-time, you can still have big impact. Like, for example, you'll hear about complex numbers support in PyTorch. And the very first patches for this support came from Dylan Bispalko, a guy who normally works on RF semiconductors for a living. Next slide, please.
Oops.
Yep. Even little patches and aggregate make a huge difference. In fact, like 13% of all non-Facebook pull requests came from people who otherwise contributed only once this year. And that's a lot of bug fixes, documentation fixes, and small improvements. Next slide, please. And that's only scratching the surface. Just as important are the community ecosystem of libraries and projects that build upon PyTorch. We have over 40 official ecosystem projects maintained by a huge variety of people. And the ecosystem is a huge part of the reason people say, I love using PyTorch, because whenever there's a new paper, I can easily go find the PyTorch code for it. Next slide, please. So what drove adoption? The answer is simple. PyTorch is easy to use. It allowed researchers to focus on their research and not get tangled up in the framework complexity. And while this seems obvious in retrospect, it's amazing how many times we underestimate the importance of hiding complexity and get surprised that things like raw performance aren't actually as important as we initially thought they were. Next slide, please. And that became even more important at Facebook when the number of engineers whose primary role was to train models all day, every day, started to grow significantly. You can just, yeah. At some point, we looked around and saw thousands of engineers leveraging our system for machine learning, and that number was growing rapidly. And wow, look at that computational requirements of all that ML work resulted in 8x increase over the same 18-month period, and that's exciting. Next slide, please. Ultimately, these are the 4 guiding principles that we worked with. Our community is in the center to empower us to build out PyTorch for enabling cutting-edge research, PyTorch to be highly performant with production-grade quality, and the PyTorch ecosystem for a smooth user experience and high productivity. You may need to click through a couple of slides. All of these things are things that I've already mentioned. Yes, right here. And the only way the ML community scales is they help each other. A single framework team cannot do all the software development needed for the team. And it's also a natural regularizer to avoid overfitting to the ideas of a few. This is a small subset of the PyTorch ecosystem, but good examples for organic growth. Next slide, please. And we recognize how small we are. We have always strived to play well with everyone in the Python ecosystem and beyond. And we're not going to have all the innovation and ideas ourselves. So this is our lightning fast overview of PyTorch. And I thank you for your time and attention and this opportunity. And I hope to see you around the PyTorch forums. Thank you.
Thank you very much. Let me see if I can stop sharing my screen. Okay. Sorry, am I still sharing my screen?
I see a blank screen though. Yeah.
Let me see, I don't.
Yes, but it's black.
Yeah, okay. So how do I stop sharing this? Can I, if I do stop video, do I stop share or do I stop the recording? Sorry about that. Can somebody, oh, sorry, there it is. Didn't see the right button. So thank you very much, Diodi. I saw that there were a number of questions already in the chat. I don't know if I can pick this up. Trying to manage a few screens here at the same time, and there's one question here. Jyoti, I will just do one, and then we go to the Q&A later on. So one question I got from one of our attendees is, with science and technology advancing in flexible and innovative ways, there may be issues of standardization and comparability. So how do you see standardization taking place within the space that you are working? And the other one is on, is there, how do you see this with relation to the work that you are doing with relation to digital divide in countries and access that they would have to systems if we look at it at the global scale? To you, Jyoti.
Yeah. So in terms of standardization and comparability, I would say that establishing interoperable frameworks, also the fact that collaborating with ecosystem partners, ensuring that there are standard frameworks, standard tools, libraries that researchers and engineers could use is our path to go forward. We don't see a top-down approach at all. We see a very collaborative approach with PyTorch. So that's that. What was the second question again?
So the second question is on the digital divide. Is this so your open source community? Do you see that this is something which is worldwide? It's accessible everywhere. Anybody can participate. So that's, I think, where the question goes.
Oh yeah, definitely. It is worldwide. Anybody in the world can participate, can submit pull requests. That was one of the slide I had where a lot of pull requests come in across from different users who are not necessarily in US at all. So and who don't work on PyTorch full time. So that was the example I gave about the person who works on RF semiconductors for a living. So you could be anywhere in the world, participate and contribute to this open source community.
Thank you. So we'll pick up further questions in a panel discussion. Thank you very much, Jyoti, for this presentation, and we'll move on to the next presentation, which is by Oliver Mahoney. He is the International Program Manager at Data Science Campus for the Office of National Statistics in the UK. He's also International Policy Advisor at ONS. Oliver is the UK lead for the joint ONS-UNECE Machine Learning Group 2021. That's where he will speak about today. And he, in general, coordinates the UK participation in international fora and helps raise the UK statistics profile in areas of data science, statistical legislation, ethics, and regulation. The floor is yours. Please go ahead, Oliver.
Thank you, Ronald. Hopefully I'm coming through okay. Thanks for letting me join today. So I'm going to give a quick introduction to the Machine Learning Group 2021, which the ONS, or Data Science Campus, coordinates alongside the UNECE, and I'm joined by Inkun Choi, who is going to support me hopefully in the Q&A on this. And hopefully I'm going to provide some key observations that we've had leading on this, particularly delving into what we're observing about machine learning in the official statistical space. So there's a quick quote there for an introduction. I won't read it, but I think obviously this applies across the board within the data science machine learning space, but it's certainly the case for us in official statistics, us national statistical organizations, us NSOs. We have a large amount of historic data, which we're still building to this day through our business as usual with surveys, and we're increasingly getting access to increased amounts of admin data and private data. And then finally, we're known for our expertise, hopefully, in data management, typically because it's underpinned by very strong legislation domestically. So there's certainly a lot of space for machine learning to add value here. And what we're seeing through the group and beforehand was that implementation varies amongst NSOs. even those that we consider developed, such as ONS. But the challenges to this are typically shared between organisations developed or still developing. And that's where our group, MR 2021, aims to build on the momentum of a previous project under the high-level group for the modernisation of statistics and step in and sort of foster a community to investigate. So we have three main sort of objectives. We're a platform to facilitate research and modernise official statistics, particularly alongside pretty common refreshed national strategies on data science and acquiring like private data and working with our private partners. We want to build capacity in machine learning, and that's domestically with our own organisations and with our capacity building partnerships, and globally with our international organisation partners. And of course, we want to facilitate the sharing of knowledge, and that's through data, methods, results, and challenges, and providing the appropriate forum or fora to do that. We're completely community driven. Our projects and activities are led by the members, and they're also informed by the membership, which numbers in greater than 250 members now, and from 37 plus different countries and international organisations. Our decisions are informed by consensus, but we're also guided by the HLG Master Executive Committee. But thirdly, and most importantly, we're for the public good. All of the group itself is open to all official statistical bodies, not just those limited to the UNECE region, and we welcome anybody at any level of expertise. So statisticians starting off within their data science journey, or those at the sort of top or tail end of their career who really have the ability to share their experience and best practice. And then finally, our resources aim to be completely available and public, and if not, in that slight chance, they will be just within the group, which is also open. So this is just a quick look at, or at least from February 2021, what we look like. It's changed a little since then. These work streams are informed by the membership, and sort of we decided that through discussion and through the group, and I'll quickly run through these. So work stream 1 is very much that proof of concept phase, proving the value add of machine learning in particular applications from ground zero, whether that's imagery, satellite imagery analysis, imputation, coding classification. We've got a good variety of different applications there. Work stream 2, once we've proven that concept, that value adds, how do we actually include this into our workflows? And this is a really difficult barrier to a lot of NSOs, and something we're really trying to focus on. Work stream 3, data governance and ethics, particularly the former. This work stream is looking to see and develop some ethical principles that should be applied to applications which they're altered for machine learning. So what more do we need to consider now machine learning's been included within the production cycle? Work stream 4, the quality of training data. So this group are really trying to identify and describe circumstances where they need to retrain the models, how they can detect that it needs retraining, and hopefully create some criteria, objective criteria for automatic retraining. And then finally, the quality framework for statistical algorithms in workstream 5. This was a product from the previous project, and this group are trying to sort of apply the framework to existing applications and explore some dimensions to almost stress test it. I will say that all of this is underpinned by various events that we host. For example, we do coffee and coding events where we really get into the detail of specific coding of applications, which helps really share workflows and processes much more than just a high-level summary, and we're also a hub for training materials and seminars, etc. So thinking about that sort of work stream 1 and a bit of work stream 2, what are our sort of high-level observations about machine learning and official statistics, particularly from our perspectives as the coordinators? The first one's hopefully a bit obvious. Machine learning has a lot to add in areas where automation is, well, in areas of ingrained labor-intensive and time-consuming processes. Particularly, we think of coding and classification being one of these most promising areas. We've seen that it's transferable quite easily, and that it can be implemented to various degrees. So it could be used to triage data points in a data set, or it could be slightly unsupervised. I'm not going to say it's going to be fully supervised just yet. I think I wouldn't be doing a presentation in 2021 without mentioning the pandemic. Sorry, but it's very important still in this area because it's changed what official statistics fit for purpose means. Timeliness is now more important, particularly to our policy makers and our users. And this is very much emphasized by quotes. Another one, sorry, which came out from a recent sprint from the national statistician of Hungary, who said, if we stick to our usual rigorous standards of accuracy, we may be producing historic data, but not relevant data. And that sort of emphasizes the importance that timeliness is taking in our current operation within the COVID pandemic. And I'm not saying there's a trade-off between quality and timeliness. I imagine there's a lot of debate whether there's an equilibrium level of that, but that's a debate for another time. And then beyond the methods, beyond the proof of concept, what happens post that? The previous project had proven, in the words of Claude Julien, who led that project, that ML isn't just a buzz. But I think we're finding that there are no quick wins. Many NSOs are easily able to prove the value adds, but they struggle to build the momentum to implement, or they simply just don't know how to. So there's very much space to explore how to build a business case for machine learning applications. How do we need to show the benefits, long-term risks and mitigations, and improve other things. So ethics, public acceptability, particularly trying to show the importance of and communicating human in the loop. And then there's obviously technology, which varies differently in terms of being able to get the technology. I'm thinking graphics cards. My poor gaming PC can testify to that, but also even things we think of as basic, which other developing NSOs won't be able to sort of relate to. So that's another area that we need to explore. And we are attempting to answer these questions, but there's still plenty of room for improvement and further exploration. I'm thinking of knowledge transfer as well in two separate dimensions. So there's making sure that we're connected, because there's lots of work going on in the official statistical space internationally. Particularly, I think of the UN CEBT, the Global Working Group, as I still like to call it. But there's great work there that we need to connect to. Andrew's task team, for example, or the task team on skills that we need to connect to really make the transfer and creation of learning materials quite efficient. But there's also the knowledge transfer, NSO to NSO. We want to look into, or at least we need to observe how to create success, how to find out how someone brought something to pilot and have them be a mentor to other NSOs. There's a lot of success there, but we need to standardize that so we can sort of facilitate it and foster it a bit more. And of course, given who is in the virtual room with me, we can't forget the wider ML community beyond official statistics. There's a place for public-private partnerships in here. They're really important, particularly when we see that admin and private data can augment our existing statistics, but also sort of inspire our methods. Unfortunately, / fortunately, they are far ahead in terms of methods and technology than us, so we have a lot to learn. Again, thinking of Andrew's task team, privacy preservation, that has a lot to inform, particularly NSO to NSO data shares, which I know has been a bit of an overall final wish for the statistical community. But there is a balance there between that public and private operation, and we need to find that. But again, that's probably a debate for another time. Some quick links just to wrap up. Hopefully I've shown there's potential for machine learning in the official stats, but there's so much more. It's not just a quick cut and paste. A lot of work still needs to be done. So thank you.
Thank you very much, Oliver, for this run through of this 2021 machine learning group led by the ONS UK within the official statistics coming out of the work being done under UNECE and the Conference of European Statisticians. So there is a question which I will take to the Q&A session, which is, and I will already mention it, but we'll come back to it later on, which is in how far gender diversity in developing unbiased AI or ML products is needed. So in what way also do we need to make sure that there is kind of gender parity in workplaces like a data science campus. We have two of them here, but more generally in those workspaces too. So has that been under discussion? So just we'll take that to the ANI session later on. But think about it. Has it been part of the discussions, either in AI solutions or ethics or otherwise, in how far also gender balance is really important? Now, a quick question right at this moment. So you mentioned that it's really an official community of official statisticians, experts there. You do like to reach out to partnerships with other communities. Where do they meet? So do you have projects which include experts from other communities, or is it really very much driven by the statistical community, and you're reaching out sporadically?
I think Inken would very much testify that the community itself is a bit of a test subject within official stats. So we're very much open to sort of seeing what fits, to be honest. We do have, recently, there's a good example, the AIS data task team within the global working group, or not the global working group anymore. Trying to see where we can sort of find that sort of cross-pollination of ideas, whether that's just bringing a presentation to the wider group as we meet every month, or actually trying to get proposals and people to join in within the specific work streams. So I guess my answer is all of the above in terms of actually trying to get them involved.
Okay, thank you very much, Oliver. We'll move on to the next presentation. That's by Professor Bertrand Loison. He is Vice Director of Director General of the Swiss Federal Statistical Office, and is also the head of the Data Science and Statistical Methods Division of the Swiss office since November 2020. Bertrand was in previous positions, among others, also the Chief Information Officer of FSO Switzerland. Currently, Bertrand is president of the National Planning Committee of e-Government in Switzerland, and he represents Switzerland in the UN Committee of Experts on Big Data and Data Science, and he's also a member of the International Advisory Committee for the Regional Hub for Big Data in China. Further, Bertrand is an honorary professor of information systems at the University of Applied Sciences and Arts of Western Switzerland. With that introduction, Bertrand, I'll give the floor to you. Thank you.
Yeah, thank you very much. Thank you for inviting me. Yeah, I will spend the next 10 minutes trying to explain a little bit what that means to have to run the Data Science Competence Center for the entire federal administration. I will present 3 different perspectives in order to do that: the organizational one, analytic services, and at the end, the data perspective. And then maybe to understand where we are coming from, we started many years ago asking the question if we can use big data and non-traditional data sources. After that, we launched many pilot projects, wrote a data innovation strategy, and it was necessary last year to decide what we want to do with the topic data science. And we asked the Federal Council if we can create a data science competence center, and the answer was yes, it's a good idea, but this data science competence center has to offer services not just to official statisticians, but to the entire federal administration. It was quite a game changer, this decision, and now that you have an idea, we are attached to the FSO. We provide services for official statisticians, but also to close to 90 other federal agencies or offices, and we cover many different topics. The key idea was to reuse what we learned. For example, if you have a project that has to do with migration or energy, that you can reuse the concept and what we learn for another offices or agencies. And maybe the question is quite interesting for the official statistician: why data science and AI for public good at the FSO. I will pick up two main reasons why it was quite important when the Federal Council decided that, because it's really our core business to create insights from data, to learn from data. It's for one important thing, and the other one, it's the last point of my slide, because official statisticians have to respect the code of practice and the UN fundamental principles of official statistics. And we'll speak a little bit more about that. At the end, we have this construct. We have the offices for the federal administration. We have signed agreement with academic partner, and we are the bridge between. And we also offer services, and we are the bridge between these different partners. And I was asking myself more than 1 year ago, what is the USP for such a data science competence center? And I found this code from Boston Consulting Group quite interesting, which means finding data scientists that are very good at what they are doing. They know every new algorithm. It's maybe not simple, but it's possible. But you need to trust the institution that is doing that is running data science. And that's the reason why we decided to define our core values very close to the principle of official statistics, where explainability, transparency, ethical handling are at the core of our work. How it works, as I mentioned, we signed many partnerships with academic partners, universities. They bring us data science expertise. And they bring us also a platform as a service for collaborative data science named Renku. We are providing data science as a service, and not just expertise, but really services to the federal administration, and we try to stay connected with other similar initiatives. And the offices, they are coming with questions, with requests for collaboration about more or less everything, which means how should I ask the right question? Do I have the right data to answer the question? Which kind of algorithm or model should I use? How can I put that into production? How can I disseminate these results? And so on. That's a little bit the construct. At the end, we are the bridge between these three partners. We are becoming a lot of question requests for project, and we have to deal with many different kind of data. But what's the point really that is important is that's what I mentioned in this blue box, the non-discrimination, explainability, the ethics, because it's absolutely crucial when you work for the public services that you can guarantee that for your citizens and also for the companies that trust you at the end of the day, that you produce results that are that match with the expectation that you can have when you work for the public service. Analytic perspective, we have two kinds of motivations. People that are coming because they want to generate new insights for detection, maybe new scenario or pattern recognition. That's one thing. The other kind of demands focus much more on productivity gains, which means that they want to automatize something. But if you try to take a little bit distance, at the end of the day, you see that data science and AI, generally speaking, are based on statistical models. And our code of practice of official statisticians enable to have explainable data science and AI for the public services. We offer these services. I don't have time to describe in details every services that we offer, just to say number 1 and 2 are currently really the service that we provide to other offices. They need really consulting regarding the potential of data science and AI, because it's not something that is that maybe now. And the second one is really the capacity to pick up and to choose the right model, to assess the model, and to be sure that what we produce are state of the art, the model that we pick up. And these four services are offered as, of course, in accordance with our core value. And now it's very nice to have analytic services, but you need to have data and make it very quickly. We solved the problem of national interoperability. We will launch tomorrow interoperability platform, which means we will create at the national level a data catalog where we will have an overview about the metadata, which means about the data that are stored in federal offices, cantons, commune, companies, research, and so on. And the key idea is to join storage as a centralized metadata, but decentralized data storage. And I'm personally very convinced that we need to invest in privacy text in order to have access to this data, because every single law has other rules of engagement for this data. And internationally, and I won't explain that in detail, we don't have time, but we still have some problems that are not solved. We have unsolved problem, for example, data stored on platform like Airbnb, Uber, or another one outside of Swiss law jurisdiction. We have ongoing needs to access to this platform. And the final goal should be to have fully automated data pipelines, but we are currently far away from that. And I mentioned on the left side of my slide, the challenge that we have to face in order to maybe one day achieve this point. So I'm finished with my presentation.
Thank you, Bertrand, for this presentation. There's a lot of information in what you've been presenting. As you indicate, you could probably spend an additional 10 minutes on each of the slides to explain further. One question I have, I think, is a little bit at the core of what you are trying to achieve with the Data Science Competency Center. So you want to use an expertise in data science for official statistics, and also open up competencies of official statistics with the data science community on both sides through the various governments and so forth, government offices. And now traditionally official statistics has been very closed off, right? Because trust, as you said, is the main anchor of what the work that we do. And if we start opening this up, it's more difficult to guarantee confidentiality, guarantee how data are used, make sure that quality is there. So the question to you is the steps that you see in opening this up. I posted to you earlier, is like statisticians in the Federal Statistical Office have to put an oath that they obey with all of these code of practice. Within the rest of the government, that's not the case, but you will like to work with them also on sensitive data. So how do you balance that? So I think that's the question. I think it's a question to how can you be open to other communities? Go ahead, please.
Yeah. As your question, again, you have two questions. The first one is, so we are organized, we have two sections, so two groups if you want. The first, but all employees have to sign the same kind of contract, of course. And what we offer is, at the end of the day, we act as a service provider. It depends who gave the mandate. If the mandate comes from official statistician, we will respect the rules that you apply that you have to apply to produce official statistic. If the mandate is coming from another federal agency for administrative purpose, we will apply the rules that outside that are available for this office. The added value is really to combine the knowledge and the skill regarding the way you deal with data, the knowledge and regarding the method that you apply. And I think we shouldn't underestimate the fact that data science is not only something that is reserved to official statisticians, which means official statisticians can have gain efficiency, maybe new insight, but other federal agencies are facing exactly the same challenges. And I think having a really powerful competence center that are able to deal with both, but respecting the law, of course, is, in our view, a huge advantage. I hope I answer your question.
Yes. No, definitely, and we'll take that also to the general discussion because I think it's specifically for the webinar that we have today. We have the various communities together. The data science outfits, like the Data Science Competence Center, is how you say this. Shows that that the community of official statistics is opening up towards new kinds of areas, new kinds of working relations, and I think that's what we want to get to in the Q&A session. So thanks for that, and I move to Andrew Trask. He's leading the Openmined community. Andrew's a PhD student at Oxford University. He's also active within the task team. Has been mentioned a few times, this task team on privacy preserving techniques, and Andrew and his group are leading the development of e-learning courses in that area. Andrew, please go ahead.
Thanks for having me. So I'll share my screen and maybe just confirm that you can see it and that it looks intelligible. How's that?
Yes.
Excellent. Thank you for having me, Ronald, and obviously thank you everyone for coming. So for the next few minutes, we're going to be talking about data science in the context of sort of remote data access. So we're going to start with kind of one key question. Is it possible to answer questions using data that we cannot see, that we don't have access to? And the key premise here is that you can't access most of the world's data on your problem today, meaning that you, in your own organization, you're working on important problems relating to what's going on in the world, and that you have a copy of a certain amount of the world's information on that problem. And sort of the starting assumption here is that there is a lot of other information relevant to that problem that exists at other institutions, right? So a modification on our sort of key question is it possible to answer questions using data at an organization that isn't yours? Meaning that you are within your NSO and you want to answer questions using data at another NSO or at a private business or in another government or jurisdiction or department without necessarily having to go through all of the heavy process to sort of obtain a copy of that data, if it's even possible for you to obtain a copy of that data at all for various regulatory process, administrative cost, or privacy related reasons. So so we're going to walk through a sort of a new set of techniques that are kind of on the bleeding edge of data science tools, and really explore this question. So as mentioned by Ronald, I lead a community called Openmined. So we're an open source community of a little over 11,000 folks in sort of a Slack and GitHub and a charity, 501c3 charity based in California. And we're looking to lower the barrier to entry to privacy enhancing techniques, especially in the context of data science. So today I'm going to be talking to you about a tool for data science called PySift, which sort of augments existing data science tools with the ability to work remotely so that you can use them on data that you don't actually have a copy of. The first tool that we're going to talk about is called remote execution, right? So, and we're going to start kind of like with the sort of maybe simple and more obvious things and sort of work our way through to sort of the more complex ones. So, first things first. If I wanted to use, actually, so today we're going to be featuring PyTorch again, so shout out to Jyothi, a huge fan of PyTorch. And today we're going to be talking about, how can I leverage sort of this really powerful data science tool on data at a different institution. So if you're familiar with most statistics and data science packages, they have sort of one core primitive, which is sort of a tensor or an array, right? Meaning some sort of nested list of data. And we're going to introduce a second core primitive. So like when I say a tensor array, I mean like in R you have arrays, in MATLAB, in whatever tool you have. And that's where all your computation happens. And we're introducing a second core primitive, which is the worker, right? And so in this case we have a variable called hospital data center And that's pointing towards an actual machine, an actual computer sitting somewhere else in some other hospital that we don't have access to, called May Clinic, right? And so let's say I create this tensor, using standard PyTorch API, and I call .send on this tensor, right? And now what's returned to me is a pointer. So this object has the full sort of expressiveness that PyTorch normally has, right? Where I can do all sorts of machine learning and sort of advanced statistics. But now, whenever I do an operation, like I would if the data was on my own machine, under the hood, it actually sends a message out to this hospital and runs the computation there, right? And what it returns to me is a pointer to that remote object. So this is sort of standard remote procedure call if you're familiar with that sort of computer science narrative. And importantly, if I wanted to then ask for my result, I have a special method called .get, and we're going to come back to that in a little while later. So I hope you sort of get this first sort of archetype of like, okay, I've got a pointer to a remote machine that is hardware that someone else controls, and I have the ability to use my data science tools on that machine without ever having direct access to that machine. And this .get method is we're gonna find it has some important gatekeeping and role to play. So what's the great thing? So for remote execution, some data that I want to work on can remain on a remote machine, and I can do data science on it while it lives there. But there's a second question of like, how do we actually do good data science without seeing the data, right? So the second example is just, search and example data. So let's say I've got, another connection to a hospital. I want to look for data related to diabetes. It returns to me a collection of data set pointers. So same pointers we talked about before. I can look at descriptions. I can see, how the data was created and basically view all the public metadata about this data set without actually seeing the individual rows myself. And it turns out we can actually get pretty far with this, right? This is sort of pretty useful, and maybe if there's sort of sample data or data that looks similar to or synthetically generated from the remote data set, I can really get a visceral feeling for kind of what the data is that I'm working with, right? So even though the data stays on the remote machine, I still have sort of the public metadata that I'm able to work with, right? So we have remote procedure calls, now we have search on sample, but this doesn't solve all of our problems. What about this mysterious .get function? If you remember, I had a pointer to a variable in a hospital, and I just called .get on that pointer, and then I downloaded the data. Couldn't I just use that to pull down all the data? Well, this is where things start getting interesting. So the third tool we're going to talk about is called differential privacy. So let's say I have a database of data. It's got these people, Bob, Bill, Sue, John, Joe, and the ones and zeros correspond to true and false or something like this. The goal of differential privacy is to ensure that statistical analysis doesn't compromise privacy. More specifically, it's to ensure that a query against a database, the result of that query, cannot be reverse engineered to learn information about specific individuals. Okay? And this is, I'm introducing this in sort of the sense of a database, but we also can view it in the context of sort of very advanced queries, like it's true for sort of SQL style stuff, but also if I'm remotely controlling a machine learning model that's like doing all sorts of crazy computation and I'm downloading the resulting model, we sort of consider that to be a very sophisticated type of query, right? And we can apply differential privacy in that context. And just to give you a semantic understanding of what differential privacy is, sort of the output of your query is considered to be sort of perfectly private if the output of the query is the same between this database that I have on the left and any identical database with one row removed or replaced. So meaning if I took this database and I queried it, right? And then I queried it again, but with John removed, and those two queries were the same, that the results of those two queries were the same, well, then I would know that the removing of John didn't change the answer. And if the removing of John didn't change the answer, then the answer that I got isn't dependent on John's data specifically, right? And if I can provide that guarantee for everyone in the database, and that's sort of perfect privacy, right? And so differential privacy gives us an ability, sort of based on this sort of semantic definition of the degree to which the output of the query changes, affects the degree to which it's leaking privacy, sort of gives us a way to measure the amount of privacy leakage and be able to respond to it with various privacy mechanisms. Now, for sake of time, I'm not going to go into exactly how those mechanisms work. Let's jump straight into how this works in a differential privacy context. So let's say I've got a pointer to this remote data set at another institution. Maybe this is a data set, at another national statistics office, or at a private business, or whatever. And I call this .get function. Whoa, I get a big error. It says, you just tried to request a data point which is private, or which depends on data which is private. You can't do that. You can only query private data if noise is added using one of these differential private mechanisms. Use .get epsilon to add the appropriate amount of noise. And this is really, really important. Epsilon is a measure of privacy leakage, which means that I, as a data scientist, have a privacy budget against this remote data set. And I'm allowed to download as many results as I want, as long as the sum total of all those results stays under the privacy budget, right? And that's sort of the essence of how differential privacy can be used in this context. And that gives sort of a mathematical upper limit on the degree to which I could answer sort of private questions about the remote data set that I'm not supposed to be able to answer in the process of acquiring these results that I care about. So obviously we've got some really nice tools here, but there's still some other challenges. Like, what if I want to do a join or computation across multiple different data owners? Like, I want to do a join, I've got 2 hospitals or 2 NSOs, and I need to do a join across both of them. Do I have to put both their data in the same place, right? Do I have to pick one of them to move their data to the other? Like, how does that work? So we're going to walk through one more tool called secure multi-party computation. The textbook definition is that multiple people can combine their private inputs to compute a function without revealing their inputs to each other. But I like to think about it more like multiple people can share ownership of a number. Okay, let me show you what I mean. So let's say I have a number 5, and I split it into 2 shares. Think of this like shares in a company, right? Like, these are controlling shares of this number 5. So 2 + 3 = 5. That's how this algorithm works in this example. So I'm going to take these shares and I'm going to give them to Marianne and Bobby, right? And then I'm going to disappear. And so between Marianne and Bobby, they can only see their own share, but between them is this 5 that is stored basically as a function of these 2 shares, right? And first, it's encrypted. Neither Marianne nor Bobby know the identity of this 5 because they can only see their own share. And the other person's share could be literally any number. It could be positive 1 billion or negative 1 billion, right? And this would affect the share, but neither Bobby nor Marianne can see all the shares, so they can't actually see the value. So it's sort of encrypted between them. And second, it has shared governance in the sense that, the number can only be decrypted or used some way if all of the shareholders agree, okay? So let's take this into the context of data science. Let's say I want to do some computation. While the numbers are in this shared state, there's a huge host of algorithms that allow us to do data science and sort of statistical operations, or in this case, basic arithmetic, while the number is in this encrypted shared state. So in this case, if Marianne takes her share and multiplies it times 2, and Bobby does the same, that turns into a 4 and a 6, and now we've multiplied our 5 times 2 while it's in this encrypted state. Pretty cool stuff. And the key insight here is that models and data sets, the key assets in our statistical techniques are just large collections of numbers. They're just which we can individually encrypt, right? And so if we think about this in the context of data science, right? So I've got my PyTorch tensor. Instead of calling .send, now I call .share, and I list a set of different shareholders. And now I can still do normal sort of data science type stuff, normal arithmetic type stuff, but the underlying information can't be seen by everyone who's participating. Meaning I could have some data from Bobby, some data from Marianne, some data from one NSO in one part of the world, and some data from another NSO in another part of the world. We all SMPC share across all of us, and then we can do computation without anyone having to reveal their inputs to each other. Pretty cool stuff. So this solves a lot of really important problems. And this brings us back to our sort of key question, which we'll finish up the talk with. Is it possible to answer questions using data we can't see? And I hope that you can see that sort of there's an ensemble of data science techniques that are coming together to make it possible for you to be able to answer questions using data that's stored at a plethora of different organizations, right, that aren't your own, without you having to go and obtain sort of a copy yourself. And so, if you want to try this out at your national statistics office or similar institution, please do reach out to one of the members of the privacy preserving task team, Ronald or myself or Matjaz or other members, because we are interested in sort of helping people sort of try this out for the first time and running a series of pilots, which are really exciting. And of course, if you yourself would like to learn more about these techniques to use them in your own place, please do check out this course, which you can find at courses.openmined.org, which we built and are building in partnership with the global working group. And with that, thank you so much for your time and attention.
Thank you, Andrew, for a bit more technical side of the kind of conversation that we are having here. But to the basics of what you're saying, Andrew, is that we have sensitive data, right? And one of the projects we're going to work on is that we're trying to see if for instance, statistical offices can work together. That's just one example. Could work with each other, statistical institutes, on sensitive data without revealing the actual data to the partners, and come up with meaningful results. So just so if we move away from the technical aspects of it, is can we get meaningful answers out of this kind of cooperation between offices? I think that's where the proof of the pudding is. We're looking at, and there are some. I mean, especially on transactional data among countries, there are questions like, can we compare what you have in this transaction with what we actually have, and then without revealing that. So I think that's where we want to go to. And I think that's where this basis comes, and that's where the conversation at some point will go. Are the statistical offices comfortable enough with these techniques and what you mentioned about the level of how you call it, differential privacy,
and secure multi-party computation?
Yeah. And that level are they comfortable in sharing that, or do they want? Because I think what you're saying is also, and that's maybe a question to you, is like there can't be a 100% security on this. Is that correct? And there is a certain level of uncertainty that's within this, but it should be to the level that we guarantee confidentiality for the data that we have. So how do you see that aspect?
Yeah, so the essence of this, like you said, is that there are important questions that you want to be able to answer. So, for example, with transaction data, where maybe you have two different SOs, and you want to be able to check that both sides are actually agreeing that, hey, we saw these transactions happen, between our nations or between other nations, without necessarily having to reveal the underlying data to each other. Where so everyone agrees, we would like to have the answer to this question, but we would just rather not share all of our data with each other underlying in the process of doing that. And so I think what we look at it right now is it's sort of using standard techniques. The question is, do I send you the data set or do I not send you the data set? And that's pretty bad in terms of privacy leakage, right? So on the one, that's sort of our starting point. And so yes, it's true that when using privacy preserving techniques, you're not necessarily going to get an absolute guarantee that, like, okay, they can only answer just this one specific question that you're only gatekeeping sort of access to through these sophisticated tools. But it's way better than the starting point, which is sending them the data or not sending them the data, right? Or answering the question or not answering the question. And so I think if you think of this as like a Pareto trade-off between, like, how much do I reveal to my partners, right? Versus how much can we collaborate and sort of do things together. Right now, the trade-off is like all or nothing, send the data or don't send the data. And the nice thing about these techniques is that they push that Pareto frontier, they push that trade-off so that we can answer more of the questions that we all sort of jointly care about in the statistical community, while having much better protections than the sort of all or nothing, do we put all our data into one big server or not put our data all into one big server kind of binary question. So that's sort of how I think about it. So yeah, it's true for differential privacy. There's this notion where, if I allow you to keep asking questions about my data, eventually you'll have asked enough questions where you can start to reverse engineer some things, right? And so differential privacy gives us the ability to measure how much that is. But strictly speaking, all of it is way, way, way better than me just deciding whether to send you the data or not send you the data. So that's sort of how I think about it.
Right.
That makes sense.
Yep. Yeah, definitely. Thank you for that. I'll like to open up. We have about 25 minutes for Q&A. I'd like to open it up also to the other panelists. So Bertrand, Jyoti, and Oliver, to join into this conversation. I think where there are a few questions I could pick up from the chat. I think the general question for me will be about how the various communities can work together. So there was a fairly basic question I saw in the chat, is like, how does machine learning actually help official statistics? So that's one, right? And so examples I would have is what we've done with less sensitive data, is like the satellite data, where you do this kind of training of recognition of agricultural crop statistics, right? So you train on the data on sample survey data, you train the algorithms, and then you run this through the rest of the country and at different periods of time. But AIS vessel tracking data is a little bit similar. It's also less sensitive. But once we get to the more sensitive data, and you mentioned like in health, I mean, there at some point there was a question raised to my office on can we have comparisons of X-rays of lungs in connection to COVID? Can we see if the X-rays of lungs for COVID patients is different than for other diseases, and would that be a way of quickly see if somebody has COVID or not? And sharing that kind of information, of course, much more sensitive if we can do that. And I think that's one of the issues that you've been trying to work on. So maybe if we start off with a general question to each of you, how you see this going forward in how machine learning and official statistics can actually really cooperate and move things forward. And maybe I start with Bertrand, who started this Data Science Competency Center just recently, in the kind of projects that you are setting up, and how you see these partnerships evolving, Bertrand, and then I also try others to chime in on that as well.
Yeah, thank you for the question. It's a very interesting question. I try to answer using a statistical example and not from outside from this world. And so I mentioned at the beginning of my presentation, we started many years ago a pilot project, and now they are quite successful, and they are into production. Part of them are into production, and we use, for example, machine learning if we want to automatize some tasks. For example, if we need to, we use that for automation of Noga coding. Noga is NASE. So when we try to automatize the work that is currently done by people, or we also use machine learning in a project for social security. The purpose is to identify patterns that inside the data. Another example is where we use machine learning algorithm in the identification and of topics of an image, as a satellite and aerial images. You can find a lot of different application. I would say two kinds. The first one is to try to automatize work that is done manually currently, and the other one is really to use machine learning in order to discover new insight, which means identify new patterns. I could, in other field or outside of statistic world, I could mention for detection or such kind of things. I hope it's
yeah, and
my answer is clear. So we use that very often for data validation, so to automatize that.
Right.
More example?
No. That's good. That's good. And but that which you were not to go on too long on this, but is that mostly done inside the house, or do you also get some data science experts from outside other communities to help you with this?
I think of course we work with community, with work that has been done inside the academics partner, or with academics partner, or community in general. I think the main point, I think the right question to ask is who has the skill to understand how this algorithm works really, because we need to be able to understand how they works, and because we need to take the responsibility for the result that we create with this algorithm. And I think that's much more important to really to be able to understand what has been maybe developed or discovered or developed together inside the community.
Right. Thank you. Yeah, who wants to come in at this as well? I mean, I was looking specifically at the example of matching, right? Matching and classification is in official statistics quite important. I saw that there was like this Python record linkages toolkit, right, which has been out there, I think, for quite a few years. So that's open source community working on this kind of record linkages, which is really important in official statistics. Is any of you have a familiarity with that, or have a comment on how this, let's say, the academic and open source community can develop tools that we actually can almost immediately apply to the work that we do inside of the statistical offices? Maybe also Oliver from your group, if you're looking at that.
Sorry, go ahead.
No, please go ahead. You beat me.
I was just about to say that from a PyTorch perspective, we would love to collaborate with researchers, especially if there's tools and libraries being developed. We'd love to partner and collaborate with them and feature them as ecosystem partners. That would be a way for the open source community as well to try those tools and libraries and get feedback through pull requests and do this continuous iteration of development, which is in that research to production narrative.
Thank you, Oliver.
Record linkages point you made, Ronald. So I was just going to, obviously it's important to have collaboration with external partners, but I was just going to touch on how important it is to sort of build capacity within government, not just within our own organisation. So when I'm thinking about the campus here, throughout the pandemic, we've been very active in building data science capacity within government to sort of enable that record linkage, particularly seconding staff over to other government departments, because it very much enhances your ability to get the data and then actually link the data sets in the time limits that the pandemic mandated from central government or policymakers, etc.
Right. Thank you. Yeah, and then that specific issue is like linking various data sets is something that's of course usually important for all kinds of research. And I mean, and that opens. I'm looking at Andrew. Opens up again the question: like, if you start linking data sets, how much do we open ourselves up again for leakages of confidentiality? You said it doesn't really matter how you do it. We can apply the same kinds of techniques also to linked kind of data sources. Can you maybe elaborate a little bit on that, Andrew?
Yeah, certainly. So if you buy the premise that let's say I as a statistician could do sort of remote data science against one institution, and that we have set up some sort of governance tools like privacy budgeting and data access request portals and this kind of stuff that is a mirror image of sort of existing systems through which sort of institutions can gatekeep access to sensitive data. Extrapolating that to multi-institution, where you have sort of joint governance over statistical insights, is relatively natural with secure MPC, right? So if if I'm doing statistics, against a data set that's at, Stats Netherlands or something like this, right? And I want to look at my result, right? They're going to have some sort of formal process by which they do not actually send the numbers to me until they think it's okay, right? And so the cool thing about secure MPC is that because everyone is a shareholder of the underlying data that you're working with and the incremental statistical results that you're generating in the process, the sums and histograms and whatever that might be, then you still have to actually ask permission in the same way, but all 3 or 4 or 5 or however many different institutions you're linking across have the same level of governance to say yes or no. I'm either going to allow you to have the shares necessary to decrypt this value, or I'm not, right? And if any one of them decides not to because part of their data was used in the computation of this, then it actually blocks the whole process. And so the only reason I mentioned that in sort of the manual sense is so you get a sense that like it actually is like this sort of very hard control, even if you're working with data that's linked, because that the link via SMPC sort of has this sort of shared governance. However, with tools like differential privacy, we can also provide some level of automation so that you don't have to be online, on Zoom or whatever with these data scientists all the time, saying yes and no to different data access requests.
Right.
If that makes sense.
Yeah, and the same would hold if within government, because I think that's where Bertrand and Oliver are looking at national level. Is like they will have ministries and tax and the tax authority having a very interesting data sets that you could link and do additional kind of research, and they by themselves, even within government, are not keen to just open this up. So I think there we can have. Bertrand, have you already had some experience on this particular issue of ministries wanting to link various data sets and being a little bit hesitant in how far access can be given, because so far, as Andrew was saying earlier, is mostly done by agreements and not by using tools. So how what's your current experience, Bertrand, on that?
Yeah, thank you for the question. Yeah, we have some experience with that. I mentioned in my presentation that we started as we will launch tomorrow this interoperability platform, and the first thing that we have to do is really to have an overview at the federal level about all the data that are available currently. Something that we don't really have, and we will have this data catalog. That's the first thing. I think this is the right way to address that, and but we still know which kind of which agencies or offices have data, and it depends what's the purpose. If it's a statistical purpose, we have to respect the code of practice, and usually they have to give us the data. But I would like to highlight the point that is really for official statistics, which means they have to give us access to this data. But that's currently the experience that we have. But it's we are still in this idea or this mindset that you need to transfer the data to have access to the data, which means to see the data, and we can match the data if it's necessary. We have unique identifiers, and we can do that. But we are only the Federal Statistical Office can do that, and no other offices have get the permission to do this matching.
Yeah. So I think you go on to an important point, which is the mindset, right? The mindset that you would actually access to data means sharing of data, means transferring of data, which I think we should get to the point that it's really if you want to use data for a project, it's more in the terms of getting access to it, even if it's remote, and that's where you can get the kind of techniques that Andrew was talking about. So I think, yes, the change of mindset and culture, I think, is something that's probably more pervasive than we might within our discussions here. No, I will move to this one point I mentioned earlier, which we got from the chat, is like so one thing is talking about the data itself. The other one is the workplace. How do you see this? If like this particular question was on if you have an equal number of men and women working on AI solutions, the solution comes out better than if we would have a fully dominant kind of male projection on this, right? If I put this a little bit black and white, but so what's so this is the workspace and also, like, say, the culture of change. I think that's the other question I want to move into here. I know statistical officers, know from my own office, relatively conservative in trying to engage in modernization and data science and so forth. But I think it's important, and how do we deal with the kind of workplace and cultural aspects? Who would like to take this on first? Can I? Let me start with Jyoti. You want to, from your perspective, and having worked at both Amazon and Facebook, what's the kind of cultural and workplace aspects? How did that figure in the kind of things that you were doing?
I think I was fortunate enough to be in a workplace where talent was encouraged. So being coming in as a woman at workplace and coming in from a diverse background, I think both at Amazon and at Facebook, there's definitely a lot of encouragement to come up with fresh ideas. If there are ideas that I have or any of my colleagues have, I've seen them be encouraged. And I think some of those play a huge important role in terms of how we gain the confidence to make contributions. And they were also very important and played a key role when back at Amazon, when I was so new to machine learning 5 or 6 years back. Gave me the encouragement to learn, like the very supportive colleagues. And I think some of these aspects, I think, of these collaboration is what moves into even the open source community, where when we open these channels to like collaborate together, gone are those days when those mainframe days when we were like having these licenses around things. And I think that culture definitely seeps into the ecosystem as well.
Thank you. And Oliver, if I move to you from data science campus perspective, do you have discussions both on openness to innovation and specific aspects about how solutions that you are working on could be influenced by the people who are working on it? If I broaden that a little bit like that.
Yeah, definitely. I mean, I was going to touch on, we certainly have a lot to learn from Facebook, for example, and our other private sort of partners, because I mean, we're NSOs. We're typically, and I'm going to sort of slander my own organization here, quite archaic creatures. We're usually based on legislation which makes our organization operate in a certain way. So particularly within the campus, we're certainly pushing forward and sort of operating with different collaborative methods, learning from our private partners and giving that open space to encourage and influence our development in AI and all of our data science projects. How that influences our actual products itself, I guess a good oversight, particularly within government, is probably the best bet there. But I'm certainly not best placed to comment on the actual results of that just yet.
Okay, thank you. Yeah, I will bring also Andrew and then go to Bertrand on the same question. But from your perspective, Andrew, you've now started to work with the statistical community. It must be an interesting experience. How do you see that? What from the looking in from the outside at this community of official statistics? How do you see things developing there?
Yeah, honestly, it's great fun. I think that the mission of the statistics community is so crucial. I mean, just look at what you're trying to do. I believe in the case of, so I'm American, and I think in the American Constitution is sort of when it sort of describes sort of the mission that sort of leads to, like, for example, like the U.S. Census Bureau's mission, or if you look at what the CDC is doing and statistics communities around the world in helping us all respond to, you know, the greatest crisis that the world has faced in many decades at least. You know, sometimes you see that in the private sector, but not very often. I mean, it's like such a huge, vital, important mission that affects the global population. So from that perspective, it's incredibly exciting. And whereas I guess Oliver has described, I think, what was the word you used? Archaic creatures, I think was the phrase that you used. I personally find that to be exciting, because it means that there are lots of people who have tried out awesome techniques and new tools, and can tell us sort of about them, and sort of lead the way in perhaps sort of safer, more kind of commercial type use cases that then we can bring into some of the most important and valuable statistics and data science questions in society. So from that perspective, for me as a technologist, it's incredibly fun, because it's like there are these tools that are tried and tested that we know about, tools like PyTorch or whatever that are hardened or hardening. And we've got some of the most important use cases on the planet that we can apply them to. I mean, that's like a technologist's dream. So yeah, no, I find it incredibly fun and satisfying to get to foray into the statistics community as much as I'm welcomed.
Thanks a lot, Andrew. So moving to you, Bertrand. So you're at a really management level position within the Federal Statistical Office of Switzerland, also leading the Data Science Competence Center. And I guess you also had to go through hiring a lot of new people, setting up some kind of regulations. So what kind of considerations were also given to the kind of new people that you were bringing in, your attention to this cultural change? Could you give us a little bit of insight to that?
Yeah, I can try to give some answer. As the very important part was to find the right person to be the head of the data science section, and we spent quite a lot of time to find the right person that is coming from. He's a biostatistician, but she worked in different countries around the world, different experiences. She bring with her a lot of experiences, different mindset, and I think you need to be open for new way of work. I think you need to accept that maybe they don't have the same logical approach regarding the work, and that they have to come at work, and you need to be quite open with that. I'm quite confident about NSI and about the future of NSI, because we had to evolve over time. And for example, we relied during decades, in a century, on surveys data. After that, we need to integrate administrative data. Now we have to integrate new kinds of data. It's just an evolution. I am not even sure if it's a revolution. We just need to adapt, but to take the right decision at the right time. And currently, we try to pick up people in our organization that are coming from different horizons, that are coming from the industry, maybe for the academics. We have ladies, we have men, we have young people, less young people. It's the idea really we need to impregnate our organization from this way of thinking, and it requires for all people like me maybe to be a little bit more open regarding that. And I think but I'm very confident that we can manage that in a very constructive way.
Thank you.
Thank
Thank you for that. Yeah, I think we come towards the end of our webinar. For me, the most important takeaway of this webinar is we have various communities here. My head has always been on the side of the official statistics. We're trying to give good quality data for important policy questions and problems. And we really, I think, are at a point where we reaching out to a lot of other communities to help and improve on that. One thing is there is so much more data out there and accessible in digital formats, and a way to handle that, I think, for us makes it necessary to to link up with data science communities, integrated into the work of official statistics, which is not easy. We want to guarantee quality, we want to guarantee confidentiality, and we want to also make sure that we improve the products from our community. So I'm very glad to have had the 4 panelists. I would like really to thank Jyoti for joining. I hope also your open source community will interact with us oftentimes in the future. I thank Oliver on the data science campus. Bertrand, you're on a new mission here, and very looking forward to where this is going. And Andrew, we're working on some of the aspects of how privacy preserving techniques can help. I think it is important. It's a difficult topic, but I think getting access to more data in a very secure way is something that's really important and helpful for broadening cooperation with the statistical community. So I want to stop with that. I would thank you all for participating. We'll put the recording also of this on our website for others to have a look at, and we'll continue the discussion. So thank you all very much, and seeing you in future occasions. Thank you. Bye-bye.